Hello everyone, my name is Sebi. Today I wanted to show you the latest HDA that I've been working on, which is called Wedge Parameters. Now I will just directly show you what it does, and later I will just go in depth of why and how I ended up doing and how every little detail of it works. But to summarize, it is going to be a manager for wedging parameters and attributes in Houdini. Instead of having to make wedges one by one, as the default wedge works, you are able to target an operator and automatically synchronize it or generate the attributes that you want from it. The way it works, as you can see, it has this target operator parameter here, and then you can drag and drop or just reference any operator in your network, and it's going to mirror the parameters of the target operator. In this case, I just wrapped the noise vanes, the bob operator here, and I just made an HDA, so it's a bit easier for myself. And you can see that I have the seed, I have like normal scale and all the parameters that it has to offer. And what I can do with the wedge parameters is to fetch them all, for example, and I can create 10 variations. So I'm going to cook it. And you will see that when I look at the work item, it generated the attributes that mirror the parameters of the target operator. If now I can also synchronize it, so it means that it will automatically set the attribute names to the parameters with the proper naming, and also checking what parameter type is. For example, if it's a vector, it's going to do the components, as you can see here. And as I activate certain attributes, you will see that it automatically all gets connected. You can also target and wedge a specific parameter. So for example, the scale goes from 0 to 1, but you can individually select what ranges you want. So for example, if I want to make the scale a bit different, I can wedge the scale as I did, and it will automatically create the wedge. And here, let's say I want it from 0.2 to 0.5. So it's always going to be a bit bigger. And I can cook that again, and now my scale will always be given preference to the wedge of that parameter. This was just the overview, but now I will just go a bit in detail and yap a bit about how this kind of works and how I get to make this and actually why. So yeah, let's see. Mainly when I work in Houdini, like the complexity of networks is quite heavy, right? So it gets quite complex. And at the moment that you want to create a system to add variations, you're always going to go back to the tops, right? It's a way to generate tasks and attributes in order to create variations for your designs. The thing is that the same amount of work we put into creating the network itself, it's kind of then has to be mirrored in the top environment. It means that if you have, I can have, for example, I made this really weird, brace yourself for this, by the way. I made this weird HDA, which I'm working on generating faces, so let it give it a moment. But you can see it has a lot of parameters, right? When we, oh my goodness. So when I create this, right? So if I go inside, just to show a bit the complexity, it's not a small network. It's quite big, you can see. So the thing is that you abstract all that complexity in a set of parameters, right? But on the process of doing that, if I look at that HDA itself, if we go to the parameters in Houdini have defined quite a lot of properties, right? And that could be, for example, the range. It's also the type of the parameter. It's the size of it. For example, the shape is a float vector tree and the seed is an integer, right? And as I make them, I also try to make the ranges accurate. And that's a process that I do once. And at the moment of adding variations and creating my top network, I saw myself repeating the same process. For example, if I wanted to create an attribute for the seed and I wanted to regenerate this face, right? I would go here and say, well, I want to create a wedge. And now I'm going to add a new attribute, which is called seed, right? It starts to be quite redundant. I think you can see it. And now it goes from 0 to, I don't know, 1,000. And it's randomized. And I will create 10 variations, right? So let's go. I have here the seeds. And now I'm going to add the property. So the attribute, it's called seed. And now that I have it, because it's going to be 0, it's going to recook again. And as I activate different variations, I can create different... Damn it. Look at the teeth. So I can create like different variations, right? And I think this process of wedging individually makes a lot of sense when you are in one abstract layer above, But if you wanna, for example, randomize a whole HDA, whatever amount of parameters you're gonna have, which is quite a lot, well, I saw myself that I'm having lists like of, I don't know, super difficult to sort of manage, and it was a bit weird. So that's where it comes in. My idea was, well, if we already make the work of creating parameters, and Houdini, it's quite of a bit like Touch Designer is like a parameter-centric software, right? Then it makes a lot of sense to wedge from the parameters themselves. So that's what this does. I'm just gonna erase this seed for 1 second. I'll just make a new faces, sure. So what I can do, as I showed, if I just target this operator, it can mirror the parameters. And by just fetching them all, if I now gonna cook that, you'll see that I automatically made the whole HCA as attributes in my PDG network. And if I now say I want like 10 different variations, well, there you go. I have them. And it's very useful because, for example, here in the mouth, I have a type and there is a menu. And I don't want to check how many items I have there. I just want to have a system that fetches that for me. And in a way, to be able to synchronize it like this is also super useful because now just with one click, I get a lot of different variations, right? Let's see what this is probably not going to look good. I'm scared. Well, I just not do that. Anyway, I guess that makes a point. Now what I'm going to do is just to have an example here. I also have a sphere, but these are just default Houdini operators, so everyone could just use this as well. And I'll just show you a few applications that I found myself and that you maybe can figure out yourself as well. The idea here is that we just use parameters in order to create the wedges. And as I just showed a bit before, what I can do now is to, for example, fetch the sphere, right? So here with my new wedge parameters, I can just target the sphere and I go to the parameters. And for example, just a good start would be to randomize the radius. So if I fetch this one and I say I want 5 different types of spheres, if I cook that, you will see we get 5 work items. And each work item will store that attribute of a sphere radius, and it's a vector 3. And then each of these have a specific value. What I can do directly is to synchronize it. We see here that it's already synchronized, and I can slowly toggle them. So you see that they have very strange values. This one, for example, if I check the value, we see that it goes negative. So that's where this sort of tool comes in, is to calculate the ranges given the parameter metadata. And in this case, the radius goes from -1 to 1 as its default range. So that's what we could override. If you want to do that, you can wedge that specific parameter. It's going to grab the name of the attribute, and you can see that indeed it goes from -1 to 1. That's why it goes from this strange range. So what I can do now is to say, well, I want my sphere to go from 0.5 to 1 as a vector. And what I have to do is to cook this again. You can just dirty the node and cook it again. And now that attribute has been reshaped by the values that we gave it here, right? So it will not go below 0.5, and it's a randomized vector. For vectors, you will see there is like this uniform value. So what you can do is to have like a uniform scale, and that will set the same value for all the components of the vector. I will leave it as non-uniform, and now you can see we have 5 different shapes for our sphere, which is quite nice. What I'm going to do now is to create more attributes for example, for this noise. What is nice about this component is that it can target any operator. It's not only HDAs. Like for example, the HDA processor is only for HDA files. This is for any operator. Let's do another one, and I will target the attribute noise. So that's what I'm going to do here. You can drag it and drop it like this. You can also type it. It's not that difficult either. So if you type this, the context just gives it to you. So for example, it's a noise 1, and there you go. And now it will also mirror the parameters that we selected, right? So you can see it here. For the noise, what I usually like to do, for example, is to check what values I want to look at. Most of the times you're going to deal with like amplitude, the size of the elements, so the period of the noise, and also the offset, which can act as a seed. So that's what I'm going to target. So instead of fetching all the parameters, which is also possible, but they are quite a bit. So I can show you if I fetch everything and I cook one item, I'll show you how many it has. So it has like a lot of parameters. Of course, it's like a very chunker operator, but that's not what I want to do. I want to fetch everything. So I just want to fetch the amplitude, size and the offset. And now if I cook it again, you'll see that I only have those three. Because it's just wedges, I try to recreate it the same way. You can connect them as each other. It should work the same as it does with like normal wedging. Right now it's just not connected. The shape changes because the sphere itself changes. What we have to do again is to synchronize. And now you can see that it's actually now synchronized. So if I select different variations, now it works. We have the same issue. The general amplitude value range for the noise, it's 0 to 10, I believe. We can check here. It goes from 0 to 10. So what I want to do is to wedge this specific parameter. And then I'm going to say go from 0.5 to 1 maybe, because it's 0 center. It's just a bit better. Now I can have a bit less intense values. The same we could do for the size or whatever you want. We could actually wedge this one and we can see if we go from 1 to 3, for example. More parameters of this operator would be this fetch all that we already saw. So you can fetch everything or not. We can also sync on fetch. This is for a bit more dynamic behavior. You can use it or not. For example, if you have this toggle tone and you want to just uncheck the amplitude only, you can do that. So you can see how individual parameters are affected within the operator. And you can see that it will get back to this value. So if I put this to 0.2, it's going to restore to the value of the synchronized parameters. The same goes for here, right? These values are pre-filled once we target the operator. And that's what generates like the actual values. We can always restore here with this button. That's going to restore everything, all of them. We can also synchronize everything, and you can just toggle on or off this as well. That brings us to the output attributes. This is a menu which will allow you to target which attributes you want to synchronize or generate given your selection. By default, is parameters and wedges. So this default behavior means that it will first fetch all the parameters that you have selected. So it makes a list of parameters and then it includes the wedges that you created. That's really useful because, as you can see, it allows us to override certain things like the amplitude. What we also can do, or what this behavior will actually make, is that if we disable the amplitude, it will still be fetched because it's a wedge. For example, if now I would say that my output attributes would only be parameters, my wedges will be disabled. And now because my amplitude is not fetched and is not in the wedge because it's a parameter output, if I restore and synchronize, you will see that my amplitude is actually not targeted. This works the same way for the offset, for example, because now we have the offset as a parameter, but not as a wedge. So if I would say that my outputs are only the wedges, I could do the same. I could restore and synchronize, and you will see that my offset is now not targeted, although it is actually fetched. It's a way to allow you to control what you want actually output, and maybe over time, that's what happened to me, is that you make a very long list of wedges, and that's what you only want to output out of that. So it just gives you a bit more control of what you want to do with it. For now, I'll leave it as default. That's usually what I do. So I'll just leave it there. Just as a normal wedge, we also have a wedge count and a seed. The values, randomized values, are seeded by this number. So for example, I could add 3 variations of the noise for each variation of the sphere. So we remember have 5 sphere variations. And now because this is Houdini and it works with the wedging system, if I cook this, it's going to generate 3 variations per each item. So you can see, I'll make this a bit smaller. When I select one sphere, you see that there are 3 children from there. So for example, the first variation, if I now look at the noise, you can see it has this, this, and this as variations. You can also override the target parameters on work item selection. What a name. I actually just copied the name of the original wedge. It's a bit different name, but it's the same. What it can do, which is quite useful, is to not have expressions in your parameters, but to actually fetch and push the values of the work item attribute. What a tongue twister, my God. Anyway, what you can actually do, if you toggle this on, you will see it unsynchronizes. And now when you select work items, it will push those values without the expression. This is really useful in case you don't want the expressions to stay. as sometimes when you open back Houdini, the work item is not cooked or generated and the value stays at 0, and that can be quite annoying sometimes. I've been using this a lot for just sketching and honestly just randomizing certain HCAs or operators. I'm like, oh, I just want to see how it could work with different values without me having to do it manually. And in this way, it became a manager for that for myself, which has been really useful. You can always toggle it back off and synchronize back again, and the value will be the same. And it's also a nice way to prototype with top networks, and then when you want to actually export stuff, you already have the system and the values that regard to the same seeding. So it's a very nice way to work. Now I'm going to create one more wedge parameters for the noise too, and I'm going to rename this to color, because if we now go to the prefix attribute, that's what we're going to use. So if I drop a new wedge parameter and I connect them, let's see, I'll actually bring the color. Now my parameters are the color. As I mentioned, you can see that it fetches literally the values at the moment of targeting the operator. You can also reload them. For example, if I look at my color and I say, oh, this is like better at 5, for example, you can see that now it stays at 3.6, which is the previous value as when we target it. You can reload that, and now you'll see it stays at 5. What I'm going to do here is to fetch again the amplitude, the element size, and the offset. And I will just look at the settings, and I'm going to cook one item. And I'll just open it up 1 second. And if you see, we actually have the amplitude, the element size, and the offset with the prefix of the operator. This is quite useful because in Houdini, if you have an operator with the same name as another, it will always add a number. That means that operator names and parameter names are always unique, and that allows you to actually never have clashes. If you don't prefix an attribute, the thing that can happen is that when you chain two similar operators with similar names, like for example, offset is a very general name, it can override it, right? Because we would not have the attribute noise prefix, and it would just override those two offsets. Usually by default, I leave this on. It's a way to make sure that the attributes are unique per operator. And what I just do is to actually give a contextual name to the original target attribute, so that when I look at it, I'm like, oh yeah, this is from that specific thing. As I mentioned, you can just toggle it off, and if I actually cook it again, you will see that now it says offset, amplitude, and element size. In my opinion, it's too general. You can also add your own name. This is a default expression to fetch the name of the operator that is targeted. You can do whatever. You could also use this function, expression called OS, and OS is going to target the wedge parameters name. So if I now cook it and I look at it again, you see that that's what I'm using. You can actually use anything you really want. I think by default is what I prefer. Now again, I'm going to synchronize my parameters, and I'm going to click on different ones, so you can see that it actually works quite well already. So we have 15 different variations with different noise attributes, color as well. And now I'm going to talk about these wedge defaults. The wedge defaults basically will be what by default the wedge parameters will do. Every parameter is quite different. You sometimes have strings or menus or things that cannot really be ranged, but my preference usually is to have ranges, right? As I mentioned before, the ranges are calculated given the parameter structure. In this, for example, I said it way too many times, from 0 to 10, that's the range it's going to take. You can overwrite it with a wedge, or you can change the default structure of this. What that means, or what that is sometimes useful for, I'm just going to bring back the panes that I had here, the noise panes, is that you can actually create attributes from operators. That's actually how this started, but it became like not that useful at the end. But what I mean is that instead of creating ranges, you can initialize attributes. Let me fetch everything and show it. So what this does is to initialize the attributes of this operator. It gives the name and the default value that they have. It's really useful if you can work on them later on, right? Because if, for example, I would not prefix, instead of having to do all of them, you have here a very clean list of attributes that just target an operator. When the wedge default is as value, that's what it's going to do. It doesn't matter how many wedges you're going to have, it's always going to have the value of the target operator. We've seen before the default is going to be range and random. If you don't have it random, usually what's going to happen, just like in a normal wedge, is going to take a range. Let me show you what I mean. What's the best way to do this? Let me see. I'll make a new wedge parameters so it's a bit easier. And I'll bring the color again here. And I'm just going to fetch the amplitude. Instead of randomized, if I cook it, you will see that it says 0. That's because it's going to distribute the range between all the wedges that you generate. If the first is going to be 0, it's because the range start is 0. The last one will be 10. That means that everything in between will be the ranges between the work items. One of the last options of the wedge defaults is this round step. As you can see, when we calculate random ranges, the floats are very long. So what you could do is to round them. For example, if now I calculate it with a round, you will see that they have like a 0.1 round value. So as when you set them, they have a bit more step. Lastly, we have this wedges parameter. This is going to store all the manual wedges for each parameter that you want to wedge, so that you want to adjust ranges or values or whatever you need. And it's important to use the buttons because we don't want to do it manually, right? So for example, this location attribute is a string parameter. If I wedge it, you will see that it has different parameters as a float one. If I now cook it, you will see that it becomes also a string parameter. This avoids the process of manually wedging the attribute types, right? And instead of having to make it yourself with this approach, you can just directly fetch a parameter and it's going to check, oh, it's a string one, it's a float, it's a vector, etc. What we can do is to check, for example, this attribute blur. So you can see that it takes an attribute, for example, the position, and it blurs it, right? So the more blurring iterations, the more smoothing it does. But that's also true, and I'm going to delete this location attribute for a second. That's also true for the color. So we can see this color here. If I want to blur the color itself, if I'm going to increase the iterations, you also see that it sort of fades away. Well, we could also fetch this attribute parameter. And it's very confusing because all the names are a bit similar, but bear with me. So here what I'm going to do is to wedge this attribute blur, and I'm only going to fetch the attributes, and I'm going to wedge it. And what I get here is a value list, right? You cannot really create a range out of a string. It would be very strange. So by default, it's going to be set as value list. And for example, let's say I want the P as position, as I showed the color. And what I can do with this, for example, I can cook it, and we can see that it indeed gives us this attribute blur attributes as P. And as I'm going to look, sometimes it's going to be the color and sometimes going to be the position. Let's see if I find the position. There we go. What makes it really handy is that attribute types in Houdini usually are evaluated different if they are strings. So if I now synchronize this parameter, you will see that it also is set properly as a string evaluation one, because it's not the same as evaluating an integer or just a float parameter. For example, let's say I want to fetch this one as well, and I'm going to say blur it between like 20 and this. The synchronization, you can see that it doesn't have the backticks because this is not a string evaluation, which is really handy because now as I go through the different options, this will also change. We don't see the evaluation, but because to do that, in strings you have to middle mouse, and now we can see the evaluated result. And if I go through it, eventually we'll see that it's either the color or the position. You can also do it per wedge parameter, which is also quite useful. For example, if we have these iterations, it's going to be default by range because that's what we have selected here. But I could also say I want it as a value, and I'm going to delete it and fetch it again. And you will see that now it's set as a value. So this will be read from the default wedge type. By default, it's going to be a range. So we're going to do it again. Now you can see that we have, again, the range pre-filled for us. But you can also set it here as a value or set it as a value list. If you want to create different types of iterations, but have a set amount of them, that's how you can do it. So you can say you want either 2, 5, or 0. 0, no, it's a bit strange. Let's say these numbers, right? So now what it's going to do, instead of a randomized value from the range of the parameter, it's going to choose a randomized item from this list. So now you can see this is a 5, so we have a 5 here. This is a 10, the 10 is there. This is a 5, you get the drill. This is it for me for these wedge parameters. I hope it was not too much. It was really fun to make. There's a lot of Python in the back, quite a lot. There is a high chance that some bugs because I tried it myself, but when you sell these things, you know, a lot of people use it in many different ways, and it's really broad. So you can actually use any operator. Maybe the last thing I can show is that this is quite common to use these things, but you could actually just use it for textures. For example, Houdini 20, they introduced this Copernicus, like texture stuff, which is really fun. If I dive inside and I make like a tile, for example, it's going to take a second. But you see that you can now generate procedural textures in Houdini, which is amazing. And for example, you can change the rows, or you can change the offset, or whatever you want. Well, as I mentioned, this is going to be the same. So if you can want to wedge this thing, you can do the same thing. Just bring it up. It takes a second because this is a ginormous operator. You can see it has like a lot of parameters and probably a lot of hidden ones, but it's still the same idea. So we could now fetch these 3 ones. So let's say I'm going to get the 3 values, and I would cook it just here, for example. There's no need to hook it up, just to show it. So you can see that now if I synchronize it, it's also going to be synchronized. And now you can see that I already have variations. This is just to show how many operators you can actually wedge with this. It's really whatever you really want. At least I've been trying quite a few things and it works. But as I mentioned, let me know if there's something wrong. And now for sure, that's it for me. Have a nice day, have a nice summer, and see you later. Bye.